Welcome to Isoclima's AIA Continuing Education series. Today's course is titled Designing with Security Glazing and is approved by AIA for one learning unit for health, safety, and welfare. Isoclima's history spans decades of expertise in specialty glass. From its roots with D. Lubac Studios in 1947 to global leadership today, Isoclima has continuously advanced glazing technologies to meet evolving safety and security needs. Today, Isoclima is recognized worldwide as a leader in high-performance security glazing. Our solutions combine innovation, versatility, and proven performance to address a wide range of industry challenges. Isoclima offers a wide range of security glazing solutions designed for different threats, from forced entry and ballistics to blast resistance and acoustic security. These solutions ensure protection across various environments while maintaining functionality. Our glazing systems are applied across many critical spaces: schools, detention centers, courthouses, hospitals, and more, where safety, security, and performance are essential. This course is registered with AIA and is AIA approved and provides one health, safety, and welfare learning unit. At the end, you'll take a short test to receive credit and a certificate of completion. Before we begin, a reminder that this presentation is protected under U.S. and international copyright law. The content may not be reproduced or distributed without written permission. This course explores the different types of security glass, how they're tested, and the performance standards that define their levels of protection. You'll learn proper installation and maintenance practices and how to apply this knowledge to design safer, more resilient commercial buildings. By the end of this course, you'll understand the various types of security glass and their applications, how performance testing determines protection levels, and the proper installation and maintenance methods required to ensure long-term safety and reliability. In today's world, ensuring the safety and security of commercial buildings is paramount. Architects and designers play a critical role in creating spaces that not only function well, but also provide protection against potential threats. This section explores the crucial role of security glazing in commercial building design. We will be covering the following types of high-performance glazing. Forced entry glazing. This type of glazing is specifically designed to resist break-ins and unauthorized access. We will be discussing different types of forced entry glazing options, such as laminated glass, tempered glass, polycarbonate, and glass-clad polycarbonate, each offering varying levels of protection. Ballistic-resistant glazing. When protection against firearms and ballistic threats is paramount, ballistic-resistant glazing is essential. We will explore the different levels of ballistic resistance, testing standards, and applications for this specialized type of glazing. Blast-resistant glazing. In areas where explosions pose a risk, blast-resistant glazing provides crucial protection by mitigating the impact of blast waves and flying debris. We will examine the principles of blast resistance, types of blast-resistant glazing, and their importance in high-risk areas. Throughout this section, we will cover the importance of understanding the different types of security glazing, their applications, and the testing standards that ensure their performance. By gaining a comprehensive understanding of security glazing options, you can make informed decisions to design safer, more secure commercial buildings that meet the specific needs of your projects. Let's start with forced entry glazing, also known as attack-resistant glazing, is a specialized type of security glass specifically engineered to withstand attempts of intrusion by resisting impact and penetration from various tools and methods commonly employed in forced entry scenarios. This type of glazing is paramount for buildings or areas where there's a heightened risk of break-ins and vandalism, or where a time delay against intrusion is desired. Unlike regular glass that shatters relatively easily upon impact, forced entry glazing is designed to remain intact for a longer duration, deterring opportunistic thieves and delaying more determined attempts of intrusion. This time delay can be crucial for allowing law enforcement or security personnel to respond. Forced entry characteristics and benefits. 1. Multiple layers for strength. Forced entry-resistant laminated glazing is constructed of either multiple plies of glass and interlayers, or multiple plies of glass and polycarbonate bonded together by a polyurethane (PU) interlayer. 2. Aesthetics and daylighting. Forced entry-resistant glazing provides the aesthetics and daylighting advantages of glass with an additional level of security. 3. Versatile applications. This type of glazing can be installed in industry-standard doors, framing, and window and curtain wall systems. It can be used in monolithic and insulating units and is appropriate for retrofit or new construction. Common applications for forced entry glazing include retail stores, particularly those with high-value merchandise, banks and financial institutions to protect against robbery, schools and educational facilities, government buildings. To ensure its effectiveness, forced entry glazing is rigorously tested using simulated forced entry attempts. These tests often involve attacking the glazing with tools like hammers, crowbars, axes, and saws. Additionally, lower-level ballistic tests may be employed to evaluate the glazing's resistance to projectiles like rocks or thrown objects. Key industry standards used to test and classify forced entry glazing include ASTM F1233. This standard, developed by ASTM International, specifically focuses on security glazing materials and systems. It outlines different test methods to evaluate the performance of forced entry glazing under various attack scenarios. ASTM F1915. This standard focuses on glazing specifically for detention facilities, which often requires even higher levels of forced entry resistance. UL 972. This standard specifies requirements for burglary-resistant glazing materials, including laminated glass and polycarbonate glazing. It outlines test methods for evaluating the resistance of glazing materials to forced entry attempts using tools and projectiles. HP White TP-0500.03. This standard defines test methods for evaluating the resistance of security glazing materials and systems to various types of attacks, including manual, ballistic, and blast attacks. It classifies glazing systems into different levels based on their performance. WMFL, Window and Door Manufacturers Federation Limited. This standard provides guidelines for testing and classifying security glazing products based on their resistance to forced entry attempts. It includes test methods for manual attacks and projectile impact. Now, let's take a moment to watch a real-life example of security glazing in action. In this video clip, captured by a security camera, you'll see an attempted break-in at an office building. As you can see, the perpetrator is using a crowbar to try and break the storefront glass. Notice how the glass cracks under the force, but it doesn't shatter or allow entry. This is a prime example of how security glazing can withstand forced entry attempts, providing crucial protection and preventing unauthorized access. This demonstration highlights the importance of choosing the right type of security glazing to ensure the safety and security of your buildings. Selecting and specifying the right type of forced entry glazing depends on the specific security needs of the building and the potential threats it might face. Consulting with security glazing experts is strongly recommended to determine the appropriate level of protection, ensure proper installation, and establish a maintenance plan. Let's examine the different types of forced entry glass makeups that are available for forced entry. There are 4 common products that are used for forced entry: laminated glass, tempered glass polycarbonate, and glass-clad polycarbonate. Recognized for its ability to withstand forceful impacts without shattering into dangerous shards, laminated glass is a popular choice for security applications where both protection and safety are paramount. This type of glass consists of multiple layers of glass bonded together with one or more interlayers of polyvinyl butyryl, PVB, or other advanced materials. The interlayers hold the glass fragments together even when broken, providing an additional barrier against intrusion. Evaluated for its penetration resistance and durability under impact, laminated glass commonly undergoes tests like EN 356, which assesses its resistance to manual attack using various tools and techniques. It is widely used in storefronts, residential windows, bank teller areas, and any facility requiring a deterrent against smash-and-grab theft or forced entry attempts. Known for its exceptional strength, tempered glass is designed to shatter into small, relatively harmless fragments upon breaking, minimizing the risk of injury. This type of glass is manufactured by heating standard float glass to near its softening point and then rapidly cooling it. This process induces compression on the surfaces and tension in the interior, resulting in increased strength. In the United States, tempered glass is often subjected to ANSI ZEED 97.1 or CPSC 16 and CFR 1201 safety glazing standards, which include impact tests to ensure its breakage characteristics are safe and controlled. It is commonly used in situations where human safety is paramount. This includes side windows in vehicles, storefronts, and sports facilities. Polycarbonate glazing is ideal when high impact resistance and security are critical. Polycarbonate glazing offers an extremely robust and durable solution that is difficult to penetrate. This type of glazing is a strong, lightweight thermoplastic with exceptional impact resistance. It is significantly more robust than traditional glass or acrylic. Polycarbonate glazing is tested for its ability to withstand significant impacts. It is typically evaluated under standards like UL 972, specifically designed for burglary-resistant glazing materials. It is ideal for high-security areas that require bullet-resistant or smash-proof glazing. Common applications include protective barriers at banks, embassies, or secure mental health facilities. Glass-clad polycarbonate, GCP, is a hybrid glazing option that combines the aesthetic appeal and scratch resistance of glass with the superior impact resistance of polycarbonate. GCP consists of layers of glass on the exterior for aesthetics and scratch resistance, with polycarbonate on the interior for impact resistance, offering a balance of security and appearance. This type of glazing is rigorously tested for both impact and thermal stress. It often needs to meet strict criteria, including standards like ASTM F1233, used to evaluate security glazing materials in demanding environments, such as detention facilities. GCP is often the preferred choice for applications where security needs to be balanced with maintaining a traditional glass appearance. This includes installations in government buildings, luxury retail locations, and cultural institutions. Ballistic glazing is a specialized type of security glazing engineered to resist penetration from firearm projectiles. It's paramount for buildings needing protection from armed attacks, high security threats, or where the risk of shootings is a concern. Unlike other forms of security glass that primarily address forced entry, ballistic glazing focuses on stopping bullets and minimizing the passage of projectiles. Key characteristics and benefits of ballistic-resistant glazing. 1. Increased strength and durability. Ballistic-resistant glazing is constructed using multiple layers of glass, interlayers, resins, and/or plastic materials like polycarbonate or acrylic. Glass layers are intended to deform projectiles and slow their velocity. Plastic layers capture the deformed projectile, and interlayers hold all layers together through the assault. The layer on the protected or witness side may have abrasion-resistant polycarbonate or PET film for spall-lash splinter protection. 2. Controlled breakage. Even with heavy protection, bullet-resistant glass breakage is possible and is nearly guaranteed during a ballistic event. If breakage concerns are paramount, such as in a high-impact environment, polycarbonate products offer robust impact performance without breakage. 3. Protection from ballistic threats. Ballistic-resistant glazing is designed to resist penetration from a variety of firearm ammunition. Bullet-resistant glazing provides a safety barrier against bullets and minimizes flying glass or plastic fragment hazards, spalls or splinters. Ballistic glazing applications. 1. High-security government buildings, embassies, courthouses, and other federal buildings where the risk of armed attack might be higher. 2. Banks and financial institutions, used in teller partitions, exterior windows, and doors to prevent armed robbery. 3. Jewelry stores and high-end retailers, protects valuable goods from smash-and-grab incidents as well as armed thefts and riots. 4. Prisons and detention centers, essential in areas where the threat of gunfire or violent breakout attempts exists. 5. General high-risk areas, any facility that could be a target for armed attacks, including certain educational institutions, corporate offices, or residential properties in volatile regions. It's crucial to know that ballistic-resistant glazing undergoes rigorous testing to ensure its effectiveness. The testing process involves firing specific ammunition types at the glazing from controlled distances and angles. UL 752 is the primary standard for testing ballistic glass, involving the use of specific ammunition types to simulate real-world attack scenarios. The glass is rated based on its ability to stop or slow down projectiles from small arms fire, with different levels of certification indicating the caliber and force it can withstand. NIJ Standard 018.1 is another standard developed by the National Institute of Justice, NIJ. This standard focuses on ballistic-resistant protective materials and provides guidelines for testing and classifying different levels of bullet resistance. A critical consideration for ballistic glazing is spall. Spall refers to the fragments of glass, plastic, or bullet material that can be projected from the back, safe, side of the glazing upon impact. High-quality ballistic glazing often incorporates features or layers to minimize or eliminate spalls, ensuring the safety of individuals on the protected side. Specifying and installing ballistic glazing is a specialized field. Consulting with security glazing experts is crucial to determine the appropriate level of protection needed for your specific application and to ensure proper installation and maintenance. Let's take a look at the specific types of glass used for ballistics. Let's start with laminated glass. These are multi-layered laminates designed to absorb and disperse the energy of ballistic impacts. They typically incorporate several layers of glass and polycarbonate or other synthetic materials, with each layer adding to the ability to stop different types of projectiles. Ballistic laminates are tested under UL 752 standards, which involve firing specific ammunition at the glass to assess its resistance. The standard categorizes glass according to its ability to withstand specific calibers and types of ammunition. These glasses are used in environments where there is a potential threat from armed attacks, such as in governmental or military installations, where maximum security against gunfire is necessary. Ballistic glass, clad polycarbonate with ballistic ratings. GCP combines the hardness and aesthetic qualities of glass with the resilience and impact resistance of polycarbonate. The glass surface is treated or combined with multiple layers of polycarbonate to enhance its ballistic resistance. This type of glass is also tested according to the UL 752 standard, ensuring it can withstand various levels of ballistic impact depending on the specification. It is ideal for use in areas that are at high risk for both ballistic and break-in attempts, such as banks, jewelry stores, and other high-security retail environments. It provides a clear view while offering protection from bullets. Blast-resistant glazing is a specialized type of glazing engineered to withstand the extreme forces generated by explosions. Unlike regular glass, which shatters easily under pressure, blast-resistant glazing is designed to absorb and dissipate the energy from a blast, minimizing damage and protecting occupants. Blast-resistant glazing is a critical component of modern security measures, providing a vital layer of protection against the devastating effects of explosions. By understanding the principles, testing, and applications of this technology, architects, engineers, and building owners can make informed decisions to enhance the safety and security of their structures. In this video, we have a live arena blast test conducted in Lubbock, Texas, where a structurally glazed window system was tested under extreme conditions. The test takes place in a wide-open test field. For this blast test, the charge type was ANFO, which is ammonium nitrate fuel oil. The charge weight was a substantial 500 pounds. The peak air pressure for this blast test reaches 6 pounds per square inch, and the positive phase impulse, which measures 42 pounds per square inch times milliseconds. These parameters are critical in assessing the window system's ability to withstand blast forces. With this test, the client tested various glass types, each being evaluated separately. The top unit that failed was not a standard glass makeup for blast resistance. This test vividly demonstrates how robust structurally glazed window systems with blast-resistant glass can be in protecting against explosive impacts, ensuring the safety and integrity of buildings in high-risk areas. Blast resistance characteristics and benefits. 1. Increased strength and durability. Blast-resistant glazing is significantly stronger than traditional glass, incorporating multiple layers of glass, polycarbonate, or a combination of both, along with specialized interlayers that hold the layers together and enhance impact resistance. 2. Controlled breakage. In the event of a blast, blast-resistant glazing is engineered to either remain intact or break in a controlled manner. This helps to prevent dangerous shards of glass from becoming projectiles. 3. Protection from blast pressure. A critical aspect of blast-resistant glazing is its ability to withstand the high pressure exerted by a blast wave. This pressure can cause significant damage to structures and injure occupants. The glazing acts as a barrier, protecting the building's interior. Blast-resistant glazing is crucial for buildings that require enhanced protection from explosive events. Some common applications include high-profile government buildings and military installations. These are used in embassies, federal buildings, and military facilities where the risk of terrorist attacks and other explosive threats is significant. These buildings often require the highest level of protection to safeguard national security and critical operations. Military installations. Given the nature of military operations, blast-resistant glazing is essential for safeguarding personnel and structures. Critical infrastructure includes data centers, power plants, and other utility facilities where continuity of operations is crucial. Blast-resistant glass helps prevent catastrophic failures caused by external explosions. Buildings in areas with elevated terrorism threat. Structures in urban centers or regions prone to terrorist activities use blast-resistant glass to minimize damage and maintain safety in the event of a bomb attack. To ensure the effectiveness of blast-resistant glazing, rigorous testing is conducted according to the following stringent standards. GSA TS 01-2003. This is a U.S. General Services Administration standard that categorizes the level of protection offered by a security barrier based on its performance during controlled blast tests. Next is ISO 16933/16934, an international standard that provides a framework for testing the blast resistance of glazing systems, specifying how to measure the effects of explosions on glass and categorize their performance. These standards evaluate the glazing's ability to resist various aspects of a blast, including blast pressure, which is the amount of pressure the glazing can withstand before failure. Then we have duration, which is how long can the glazing resist the blast pressure. Fragmentation is how the glazing breaks, if it breaks, and the size and characteristics of any resulting fragments. And last we have standoff distance. This is the distance the glazing can be placed from a blast and still provide adequate protection. Let's take a look at the specific type of glass used for blast. First, we have blast-resistant laminates. These are specially engineered laminates that consist of multiple layers of glass and interlayer materials designed to absorb and dissipate energy from explosive blasts. The construction typically includes a combination of glass and polymer materials that help the glass pane stay intact or break in a controlled manner to reduce the risk of shrapnel injuries. Blast-resistant glass is tested under rigorous conditions set by standards such as GSA-TS 01-2003 and ISO 16933/16934, which evaluate the performance of the glass under varying levels of blast pressure, accounting for factors like blast duration, fragmentation, and standoff distance. These glasses are primarily used in structures at high risk of explosive attacks, requiring a robust barrier that can mitigate the impact of blasts, helping to protect the building's structural integrity and the safety of its occupants. We just covered the three main categories of security glazing: forced entry, ballistics, and blast. It's worth noting a few other high-performance glazing products that have many of the same characteristics. Let's look at three specific glazing systems: hurricane, fire-rated security, and acoustical security glazing. In regions prone to hurricanes, standard glazing poses a significant risk. Hurricane-resistant glazing is engineered to withstand the impact of high winds and flying debris, safeguarding both building occupants and the structure itself. This type of glass often uses PVB, which is polyvinyl butyrol, or SGP, which is Centriglass Plus. These are the two most common types of interlayers, which bond together the glass, even after being broken or fractured, preventing wind and water infiltration. These specialized laminates are designed to absorb and dissipate the energy of high-velocity impacts from windborne debris. Hurricane-resistant glazing systems undergo rigorous testing to ensure their effectiveness. Key standards include ASTM E1886 and E1996, which simulate windborne debris impacts and the effects of hurricane-force winds. Regional codes, such as those in hurricane-prone areas like Miami-Dade County, Florida, often mandate specific performance levels for glazing. Fire-rated security glazing provides a dual function, enhancing security while also preventing the spread of fire and smoke. This glazing combines the features of security glazing with fire-resistant materials, creating a robust barrier against both forced entry attempts and fire hazards. To ensure compliance, fire-rated security glazing is rigorously tested to both fire-resistant standards, like ASTM E119, and security standards that assess its resistance to forced entry. In environments where noise pollution is a concern, acoustic security glazing offers a solution by combining noise reduction properties with security features. Specialized laminates incorporate interlayers designed to dampen sound vibrations, reducing noise transmission through the glazing. These acoustic laminates can be integrated with other types of security glazing to provide both sound reduction and protection against forced entry or ballistic threats. The effectiveness of acoustic glazing is measured using Sound Transmission Class (STC) ratings. Higher STC ratings indicate better sound insulation. The glazing is also tested against relevant security standards if it also includes security features. Maintaining the integrity and effectiveness of your security glazing system is crucial for ensuring it continues to provide the necessary protection against threats. A proactive maintenance approach can extend the lifespan of your investment and ensure it performs as intended when you need it most. Here's a breakdown of key maintenance procedures to keep in mind. It's essential to schedule routine inspections of your security glazing system. Look for any signs of damage, such as cracks, chips, or delamination. These seemingly minor issues can weaken the glass and compromise its protective properties. Pay close attention to the seals and frames as well. Any wear or damage could affect how the glazing performs under stress. If you notice any issues, don't hesitate to address them promptly. Early detection can prevent minor problems from escalating into major security risks. While it might seem simple, cleaning your security glazing requires a professional touch. Using the wrong products or techniques could damage the surface coatings or interlayers, reducing the effectiveness of the glazing system. Always use cleaning agents and equipment recommended by the manufacturer. Employ non-abrasive tools and techniques, and avoid harsh scrubbing or high-pressure washers. Ideally, schedule cleaning monthly or as needed, depending on your local environment. Remember, a clean window not only looks better, but it performs better too. Even with the best care, damage can occur. If your security glazing sustains any damage, it's crucial to address it immediately. Whether it's a small chip or a larger crack, these issues can significantly compromise the glazing's protective function. Depending on the extent of the damage, repair or replacement may be necessary. Always consult with a qualified professional to determine the best course of action. By following these maintenance guidelines, you can ensure that your security glazing system remains in optimal condition, providing you with the peace of mind that comes from knowing your security is not compromised. Now that we've thoroughly explored the different types of security glazing, their testing procedures, and their key characteristics, let's delve deeper into how these solutions are strategically applied in various real-world scenarios. By understanding the specific threats and vulnerabilities of different environments, we can better appreciate the critical role security glazing plays in safeguarding people and property. For sectors like education, retail, and commercial buildings, where forced entry is a primary concern, laminated glass solutions offer robust protection. These specialized glass products are designed to withstand repeated impacts, deterring intruders, and buying valuable time for response. Depending on the level of risk, different options are available to meet specific security requirements. For educational institutions, there are specialized forced entry products designed with the safety of children in mind. They combine impact resistance with safety features to prevent injury from broken glass, making them an ideal choice for schools and daycare centers. Two such products by Isoclima include ChildGuard and AccessGuard. ChildGuard is designed for educational institutions. This security glazing product is constructed to resist forced entry scenarios, ensuring safety in schools. It's beneficial for protecting entryway doors, vestibules, and classroom windows from physical attacks. AccessGuard is primarily used for retrofitting existing window and door systems, offering burglary resistance suitable for environments needing enhanced security without full ballistic protection, such as retail stores and commercial buildings. In high-security environments such as government buildings, military installations, and financial institutions, the threat of ballistic attacks necessitates a higher level of protection. Laminated polycarbonate products are engineered to resist multiple rounds of ammunition, providing a critical barrier against active shooters and other armed threats. Bullet-resistant glazing can be customized to meet specific threat levels and integrated seamlessly into existing architectural designs. ArmorGuard bullet-resistant glazing is one such product that is designed to protect against various ballistic threats, making it suitable for high-security environments such as military installations or police stations, for critical infrastructure, government facilities, and correctional institutions where bomb blasts are a potential risk. Specialized glazing offers exceptional blast mitigation capabilities. This specially designed laminated glass and polycarbonate combination absorbs and dissipates the energy of an explosion, reducing the risk of injury from flying debris and minimizing structural damage. By understanding the unique security needs of each sector, glazing solutions can be tailored to provide the highest level of protection. Whether it's deterring smash-and-grab robberies in retail stores, protecting students and staff in schools, or safeguarding critical infrastructure from terrorist attacks, the right glazing solution exists for every security challenge. Two such examples would be SecureTem Plus Poly and SecureTem and SecureLite. SecureTem Plus Poly is a glass-clad polycarbonate designed to withstand significant impacts, including blast pressures, and is used in settings like correctional facilities and government buildings, where both ballistic and blast protection are required. SecureTem and SecureLite are designed for areas prone to physical attacks and burglary attempts. They are particularly useful in retail environments to prevent smash-and-grab incidents, providing a barrier that maintains high visibility and light transmission while ensuring security. Acoustical security glazing refers to a specialized type of glazing that incorporates both sound-reducing and security-enhancing properties. This combination makes it suitable for buildings or areas where noise reduction is crucial alongside security concerns. This type of glazing typically employs laminates that include acoustic interlayers. These interlayers are designed to dampen sound vibrations, thereby reducing noise transmission through the glass. The security aspect can be achieved by combining these acoustic laminates with other types of security glazing, depending on the required level of protection. The effectiveness of acoustical security glazing in reducing noise transmission is measured using sound transmission class ratings. Higher STC ratings indicate better sound insulation. When selecting this type of glazing, it's essential to consider the required STC rating based on the specific noise reduction goals of the application. While the provided materials don't delve into specific applications of acoustical security glazing, they do mention that it is suitable for buildings that require both noise reduction and security, such as government facilities located in urban areas. LexGuard laminated polycarbonates with acoustic properties. These products are designed to reduce noise while providing substantial security, making them perfect for urban buildings or government facilities where noise reduction is crucial alongside security. LexGuard offers laminated polycarbonates that protect against ballistic and forced entry threats, making it ideal for high-security areas such as detention centers, government buildings, and any facility requiring superior protection levels. Fire-rated security glazing refers to a type of glazing that combines fire-resistant properties with security features. It is designed to prevent the spread of fire and smoke, while also providing protection against forced entry or ballistic threats. This glazing type typically undergoes testing to meet fire resistance standards like ASTM E119 alongside relevant security standards, ensuring it fulfills both safety and security requirements. While the provided materials don't offer detailed information on the specific construction of fire-rated security glazing, they do indicate they are used in buildings that necessitate both fire protection and security. Examples of such applications may include government facilities, museums, or any structure where safeguarding valuable assets and ensuring occupant safety during a fire are paramount. The Inferno Light fire-resistant glazing product combines fire resistance protection, tested and listed by Underwriters Laboratories, with a wide range of laminated security products for both forced entry and ballistic protection. All right, we're in the final stretch now. Thank you all for staying with us throughout this presentation. We've covered a lot of ground on security glazing, and we appreciate your time and attention. As we wrap things up, we want to leave you with some key points to remember. In this last section, we'll share our top 5 takeaways from today's presentation. After that, we'll address some common misconceptions about security glazing. And finally, we'll go through a few frequently asked questions that we often receive on this topic. Here are 5 key takeaways on security glazing. Number 1. Security glazing encompasses a range of solutions. Architects should understand the various types of security glazing, including those designed for forced entry, ballistic resistance, blast mitigation, hurricane resistance, fire resistance, and acoustic insulation. Each type addresses specific security threats and requires adherence to relevant testing standards. 2. Testing and standards are crucial. Architects must be aware of the industry standards used to test and classify security glazing. These standards, such as ASTM, F1233 for forced entry, UL 752 for ballistic resistance, and GSA-TS 012003 for blast resistance, ensure the glazing meets specific performance criteria. 3. Application drives selection. Architects need to carefully assess the security needs of a building and its intended use. Factors like the level of threat, the building's location, and the value of its assets should inform the choice of security glazing. For instance, schools may prioritize forced entry-resistant glazing, while government buildings might require higher-level ballistic or blast-resistant options. 4. Collaboration with experts is key. The design and specification of security glazing systems demand specialized knowledge. Architects should collaborate with security glazing experts throughout the project to ensure the selected solutions meet the necessary safety and security standards and are properly integrated into the building's design. And number 5, maintenance is essential for long-term performance. Architects should emphasize the importance of proper maintenance to clients. Regular inspections, professional cleaning using manufacturer-recommended products, and timely repairs or replacements are crucial to maintaining the integrity and effectiveness of security glazing systems over time. Now let's look at 5 common misconceptions about security glazing. Number 1, all security glass is bulletproof. While some security glazing products offer ballistic protection, not all are designed to withstand gunfire. There are various levels of protection, each suited for specific threats. 2, security glazing is only for high-risk buildings. Security glazing isn't limited to government facilities or banks. It can be valuable in schools, retail stores, and even residential properties to deter burglaries and vandalism. 3, thicker glass means better security. Thickness isn't the sole indicator of security. The type of glass, interlayers, and construction play crucial roles in determining its performance against different threats. 4, security glazing is too expensive. While the initial investment may seem higher than regular glass, the long-term benefits of enhanced security, reduced risk of damage, and potential insurance savings can outweigh the cost. 5, security glazing obstructs views. Modern security glazing can be aesthetically pleasing and virtually indistinguishable from regular glass, offering protection without sacrificing natural light or views. And number 5, security glazing obstructs views. Modern security glazing can be aesthetically pleasing and virtually indistinguishable from regular glass, offering protection without sacrificing natural light or views. To wrap up this section, we'll tackle 5 frequently asked questions that architects and building owners often have about security glazing. Number 1, what are the different levels of security glazing available, and how do I choose the right one for my project? Understanding threat levels and industry standards is crucial in selecting appropriate security glazing levels. 2, how does security glazing integrate with the overall building design and aesthetics? Modern security glazing can be discreet and visually appealing, complementing various architectural styles. 3, what are the energy efficiency considerations with security glazing? Many security glazing options offer energy-efficient properties, helping reduce heating and cooling costs. 4, can security glazing be incorporated into existing windows and doors, or is replacement necessary? Retrofitting existing openings with security glazing is often possible, offering a cost-effective solution. 5, how does security glazing impact insurance premiums? Installing security glazing may lead to reduced insurance premiums due to the lowered risk of damage and theft. Thank you for participating in this course on security glazing. We hope you found it valuable in understanding how certified systems can enhance safety without sacrificing design. For additional resources or questions, please contact Isoclima or visit our website.